Okay, fine. Okay. Good evening, everybody. My name is Maximilian Otter. I want to show you a different approach to ForEach-Object Parallel. I developed this approach this year because I was very fed up with slow commands connecting to remote systems like Exchange Online or Microsoft Graph Slow. But these commands could take a couple of seconds to complete. And if you iterate that over a couple of thousand objects, it might take a couple of hours to finish if you do it single-threaded. You know, the classic approach to ForEach-Object Parallel is just give it a bunch of data and pipe it through ForEach-Object Parallel. It will take each individual item, power up a thread, a namespace, process the item, close it again, and until it's finished. Fun maybe, not so fun if you want to connect to remote systems which use a connection which is namespace dependent, because you have to reconnect every time a thread starts. ForEach-Object Parallel also needs some busyness to have a real speed advantage over ForEach-Object single-threaded. So what we can do to overcome that is keep the threads alive. Give it a working loop that processes the data in the same thread all the time. And so start the thread only once, build the connection only once, and only let the threads close when the data processing is completed. The beauty of the thing is that once all the threads are spun up, you just have to pipe a couple of numbers of the number of threads you want to create to ForEach Parallel, and thus have specific control over how many threads you want to create, how many threads you want to use, because the threads will just stay there. But where does the data come from? You have to use thread-safe data types to do that and mask them in the multi-threaded code using the using prefix. The thread-safe data types are the concurrent data types, which you can find in .NET, which are ConcurrentQueue, ConcurrentBag, and ConcurrentDictionary. They all have their advantages and reasons to be there. My favorite for data collection is ConcurrentQueue. You will need the ConcurrentDictionary later. The queue just loads like an array. You can just take the output of whatever you use, get AD user, get mailbox, whatever, and assign the variable. You can enter individual items with the enqueue method, get stuff out with try dequeue, or just have a look into the queue with try peek. It will not remove the item from the queue then. You add it to the code as you would expect it. Prepare the variable in the single-threaded code. Then in the multi-threaded code, you reference to that variable with the using prefix, and then use the multi-threaded data type as fit. The same with the connections to the remote systems. You have to build the connections before the working loop because you only want to happen that to happen once. I really recommend using Splatting here, but for the Splatting, you can't use hash tables. You have to use the ConcurrentDictionary to make it thread safe. Other than that, the Splatting is straightforward. You just use, instead of the simple hash table, the .NET data type for the ConcurrentDictionary. And also later in the code, it's the same thing. You prepare your concurrent dictionaries in the single-threaded code, eventually already build connections there to read some data in. Then when you come to the multi-threaded code, you reference to these variables with the using prefix. You should always do that when you have to use variables from the single-threaded environment, and then just connect to your resources before the working loop. What is happening once we are here? We have successfully made the threads static with the working loop currently being in action. The thread will not stop. We have a connection before the working loop, so it only happens once. And we can use whatever connection we have throughout the whole thread. And this opens the world to some crazy stuff, because it gives you the possibility to run different code in different threads. For example, you can have the first thread be just an input thread, which uses, for example, Stream Reader to read items from a data source one by one, while the other working threads are waiting for the data in another concurrent queue. And whenever it pops up, they start processing it, and thus have a real parallelized environment compared to reading the stuff from your data source, waiting on it's done, which is actually what the pipeline is doing, and then processing it. You separate the threads by numbers. You remember maybe from the beginning, I'm piping a couple of numbers to ForEach-Object Parallel, and these numbers can translate to the number of threads. So all you have to do is build an if structure, and the thread number you want to have executed a certain bit of code, you put into the condition. The trouble with it is, if you have interdependent threads, that they have to communicate. So you have to build a status variable, again, a thread-safe data type. Q works perfectly, where the input thread in this example writes, hey, I'm busy. And when it's done with reading the data, it says, okay, I'm done. And the working threads have to peek, remember peek, not take out the data, into the queue, see what the status is, and then continue working as long as the input thread says, I'm done. And that's what I'm doing now. Thank you for listening. I hope you got the idea.